All right, goal 9.3 on adding and subtracting and multiplying radicals. So let's start with addition and subtraction. To add and subtract, the roots must be the same. So square roots with square roots, cube roots with cube roots, etc. The stuff under the radical must be the same. If it's not, you're going to simplify and try to get them to be alike. And then lastly, once they're alike, you add and subtract coefficients. So example 1, 8 square root 5, 9 square root 5, so our radicals are alike. So I just add the coefficients, 8 and 9, 17 square root 5. The next example, the radicals are not alike, so I'm going to make them alike. I'm going to take 75 and make it 25 times 3. So I'm going to have 6 square root 3 minus 3. The square root of 25 is 5, with my 3 left under the radical. So 6 square root 3 minus 3 times 5, 15 square root 3. And that gives me 6 minus 15, negative 9 square root 3. In terms of showing work, if you can show less work than I'm showing, that's great, and still get to the answer, go ahead and do it. All right, so none of these radicals are alike. Square root 20, square root 45, square root 80. So 20 I'm going to break to 4 times 5. 45, 9 times 5, and 80, 16 times 5. So I have negative 7 times the square root of 4 is 2, square root 5, plus 5, square root of 9 is 3, square root 5, plus 4, square root of 16 is 4, square root 5. So I have negative 14 plus 15 plus 16, square root 5. So now I'm just going to collect the coefficients. Negative 14, sorry. Positive 15 is 1, and 16 is 17, square root 5. Excuse me. 24 is going to go to 4 times 6. 27 is going to go to 9 times 3. So 7 times the square root of 4 is 2, square root of 6 we don't know, minus 3, square root of 9 is 3, square root of 3 we don't know. So I have 14 square root 6 minus 9 square root 3. I have those radicals as simple as they will go, and I can't get them any simpler. And they're not alike, which means that I can't go any further. I can't add those together because one is a square root of 6 and one of them is a square root of 3. So that is my final answer, 14 square root 6 minus 9 square root 3. All right, cube root 16 plus cube root 28. So 16 is not a perfect cube, but it goes to 8 times 2. 128 is not a perfect cube, but it goes to 64 times 2. So the cube root of 8 is 2, leaving me cube root 2. The cube root of 64 is 4, leaving me cube root 2. So then 2 plus 4, 6, cube root 2. And then my last one, I think. Okay, 48, not a perfect cube, or a fourth root, sorry, not a perfect fourth root, but it will break to 16 times 3. And then 243 will break to 81 times 3. Now remember that you can use your nth root chart, the ones with the cubes, the fourths, and the fifths on it from the notes. You can use those to help you break up your nth roots. So I have 5. The fourth root of 16 is 2. The fourth root of 3 left, minus 2 times the fourth root of 81 is 3, and the fourth root of 3 left. So I have 10 fourth root 3 minus 6 fourth root 3. So 10 minus 6 is 4. Fourth root 3. All right, so addition, subtraction will get no harder than that. Making your radicals alike, like we did in, or simplifying them to make them alike, like we did in goal 9.1 and 9.2. So simplify them and then add together if possible. All right, so multiplying. To multiply, the roots also have to be the same. So square roots with square roots, cube roots with cube roots, etc. You're going to multiply the outsides, you're going to multiply the insides. And then once you multiply, then you simplify like we did in goals 9.1 and 9.2. So first I multiply. 3 times 6, square root 18. 18 breaks to 9 times 2, which is 3, square root 2. 5 square root 3 times 8 square root 21 is 40, square root 63. 63 breaks to 9 times 7, so I have 40 times, the square root of 9 is 3 with the square root of 7 left. 40 times 3, 120, square root 7. Six times 5 is 30, times 2 is 60. So I multiply them. 60 breaks to 4 times 15. So the square root of 4 is 2, square root of 15, I don't know. I multiply and I get 21 on the outside, the 7 times 3. On the inside I get x to the 2 plus 1 is 3. And then y to the 3 plus 1 is 4. So I have 21. And then use your divide by rule for your exponents. So I'm working with square roots. So 2 goes into 3 one time with 1 left over. 2 goes into 4 evenly twice with none left over. So final answer, 21xy squared square root x. So I multiply the outsides first and I get negative x squared y. And then I go to the insides. On my x, 4 and 2 is 6. And on my y's, 1 and 5 is 6. So then I have the square root of x to the 6. 2 goes into 6 evenly 3 times, none left over. 2 goes into 6 evenly 3 times, none left over. And now I add my powers, negative x to the 5th, y to the 4th. No radical left because everything had a perfect square root. When you see this, you should recognize that this is a distributive property. We've distributed property lots of things over the years, so you should recognize that as this. So I distribute. The square root of 3 times the square root of 3 is the square root of 9. The square root of 3 times minus 4 is minus 4 square root 3. Once you multiply, distributive property, or any kind of multiplying you do, you simplify whatever you can. So, the square root of 9, that's a perfect square, that's 3. Minus 4 square root 3. Those are unlike terms, so that's as far as you can go. That's my final answer. Here you should hopefully recognize FOIL. So first times first, 49. Outer times outer, minus 7 square root 13. Inner times inner, positive 7 square root 13. Last times last, minus 1 square root 169. The middle two terms, positive 7 and negative 7, cancel each other out. 169 is a perfect square root, it's 13. And then 49 minus 13, 36 for my final answer. Here we have another FOIL. First times first, 6 square root 6. Outer times outer, positive 2 square root 9. Inner times inner, positive 3 square root 10. And last times last, positive square root 15. So the first term, the 6 square root 6 here, cannot be simplified because 6 does not break down. This 2 square root 9 will break down to 2 times 3. which is going to give me, let's just do this to make this a little simpler. So we're going to have 2 times 3, which is 6. 10 does not break down, so 3 square root 10 plus square root 15. All of those terms are different, so that entire line, 6 square root 6 plus 6 plus 3 square root 10 plus square root 15 is my final answer. Remember that this is a power, and that power means that you have 2 of these terms. So 5 square root 10 plus 7 and another 5 square root 10 plus 7. So you're going to be foiling. So first times first, 25 square root 100. Outer times outer, 35 square root 10. Inner times inner, 35 square root 10. And last times last, 49. 25 times square root 100 will simplify to 25 times 10, or 250. So then I have 250 plus 49, 299. Back to my blue pen. So 299. And then 35 square root 10 and 35 square root 10, positive 70 square root 10. So final answer, 299 plus 70 square root 10. Here we have distributive property. Square root x times square root x to the 5th gives me square root of x to the 6th. Square root x times 5, 5 square root x. The square root of x to the 3rd, 2 goes into 3 evenly 3 times, none left over, plus 5 square root x. Those terms are different, they cannot be added, so that's my final answer. Here I multiply cube root, so cube root of 27x to the 10th. Cube root of 27 is a perfect cube, that's 3. Use your divide rule. 3 goes into 10 evenly 3 times with 1 left over. Don't forget your little cube root. So 3x to the 3rd cube root x. And then I think my last one, yep. So I'm going to have 4th root of 32. X to the 6 and 7 gives me 13. Y to the 2 and 2 gives me 4. 32 is not a perfect 4th root, but it contains 1. 16, 2 times 2 times 2 times 2 is 16. So 16 times 2. So the 4th root of 16 is 2. The 4th root of 2 I don't know. 4 goes into 13 evenly 3 times with 1 left over. And on my y, 4 goes into 4 evenly 1 time with none left over. So again, to multiply, you need to make sure that your roots are alike. Multiply and then simplify. So it's different. Addition and subtraction, you simplify first and then you add and subtract. But for multiplication, you multiply first and then you simplify. Alrighty, so that's it.